Hello everyone, myself Ved, and today we're going to discuss alkene and alkyne quiz. So this one is the very first question. The following reaction is an example of. So we have an ethane molecule and it is treated with Cl2 in the presence of HNu, and the product is ethyl chloride CH3 CH2 and Cl. And the options are addition reaction, substitution reaction, oxidation and reduction. So this one is a very simple one. So we all knew this is a free radical because it is carried out in the presence of sunlight HNu and we have a Cl2. So this is free radical mechanism, not addition, not oxidation, not reduction. This is free radical substitution. Okay, so because one hydrogen is substituted from this carbon, clear? So we have CH3 CH2 Cl. So this is free radical substitution. Makes sense? Now the second question, we have an alkene and it is treated with Br2. Okay, so we all knew Br2 is a anti-dihalogenation. Okay, so anti-dihalogenation means both bromine in the opposite side. Clear? Both bromine attach on the double bonded carbon in opposite side. So what does it mean? It means the product should be like this. So here we have alkene. So this is the double bonded carbon and Br2. So one on the wedge and one on the dash. Okay, so this is anti-halogenation, dihalogenation because both are bromine. So which option? So A is wrong because this is wedge. B is correct because one on the wedge and one on the dash. So the right choice is here, the B. Now the next question. So this one from alkyne, we can see here we have alkyne and it is treated with NaNH sodium in liquid ammonia, the right hand side, and the left one is Lindlar catalyst. So this is a very important reduction. So sodium in liquid ammonia is a trans alkene. Okay, we can say here this is trans alkene. So this one is a cis alkene. You can memorize this. Look at this Na. And this is ammonia. Ammonia starts with alphabet A. So A sounds like NT. NT is same as trans. So we can, correlate like this is trans. So A is trans, B is cis, option A. So question 4 is not right. We will discuss the next question. This is incorrect here. Okay, so we can do the next question, this one. Question 5. So it is treated with HgOAc whole twice, H2O, THF, NaBH4, NaOH and H2O. The first thing is what kind of this reaction is. So this is, in short, we can say OMDM. Okay. So this is known as oxymercuration and demercuration reaction. This is oxymercuration, demercuration. So this is a very important one, and I can tell you the trick here. This is mercuration. So mer means Marconi-Kopp's rule you have to apply. And the reagent is H2O, which produces OH minus as a nucleophile. So OH minus attacks according to Marconi-Kopp's rule. So what is Marconi-Kopp's rule? Marconi-Kopp's rule means OH minus attacks on that carbon double bond carbon which has less hydrogen or more substituted carbon double bond carbon. Okay, more alkyl chain, more carbon chain. So if you look at this double bond, you know, this carbon has less hydrogen and more substituted carbon chain. So OH attacks on that tertiary carbon. So the right product will be C. You can see OH on that tertiary carbon. Clear? So this is C. And this is very important reaction, OM-DM, oxymercuration and demercuration. Now the next is this one, number 6. Consider the following reaction. We have a tertiary, this alkene, and it is treated with HCl. So couple of questions from here. The very first question is, what kind of is this reaction is? So this is electrophilic addition. This is electrophilic addition. And if I am going to explain this, the mechanism, you can see we have a tertiary carbon in the neighboring to the double bond. So this one is CH3, 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 CH double bond CH2, and it is treated with HCl. So I will tell you the trick as well, but here the mechanism, the alkene first react with H. So we have this carbocation, okay. Do not apply Marconi-Kopp's rule directly on the alkene if there is a rearrangement, okay. This reaction is, in this reaction carbocation is intermediate. So whenever you have a carbocation intermediate, first check the rearrangement. So here rearrangement takes place because this is secondary carbocation, and if you are going to rearrange this carbocation in the neighboring carbon, and we can shift this methyl and keep positive on this position, so you have a tertiary carbocation, this one. Okay, this one was the secondary one, and this one is a tertiary carbocation here, which is a stable one. And now the nucleophile, which is Cl minus, attacks on this carbocation. So product should be this. Okay, so which option is right here? Yeah, this one, option A. Clear? Chlorine on this carbon, the tertiary one. So let me check the other options. Yes, option A is correct. Clear? Now number 7. Okay, number 7. Number 7 is, we have multiple steps here. So the number first reaction is NBS. We all knew NBS is a N-bromosuccinamide, and it gives allylic bromination. What is allylic? The carbon next to the double bonded carbon, the next to the alkene. So this one is a allylic carbon. So here we have a bromine at allylic position. The next step is HBr H2O2, and that gives you anti-Marconi-Kopp's addition of bromine on the double bonded carbon. So anti-Marconi-Kopp's means bromine attacks on the carbon double bond which has more hydrogen. So this carbon has more hydrogen because this is CH2. So this one is X. Now the Y will be this. Here we have bromine and this is bromine. Clear? The next is this Mg. So if you are going to attack here the Mg, then we all knew Mg can insert this carbon bromine bond. Okay, so anyone, both are correct here. So suppose here it is going to connect MgBr and this one is a bromine. So this is the carbon which is a nucleophile here. Can you see? Wait. Here we have an extra carbon. Yes, this one. So here we have a bromine, and when it is treated with Mg, then it would be this MgBr. Okay, like this. And now this is intramolecular attack. Intramolecular attack means this nucleophile, because this is Mg plus, so this carbon is negative, so it attacks on this carbon and bromine leaves. So we have a ring and the ring is 3-membered, and then we have a branch at here, so we have a branch. So cyclomethyl, you can see there is a methyl group on the cyclopropane, so this B is the right choice, you can see. Again, this NBS is N-bromosuccinamide, which means allylic bromination, and then H2O2 with HBr, it is anti-Markovnikov of bromine, so bromine on this carbon. Clear? And the next Mg with heat, so it means we have Mg on the bromine containing carbon, and the next attack is intramolecular attack. Clear? Now the number 8. Br2CCl4, again this is anti-dihalogenation. So if this one is a dash methyl, then here one bromine on the wedge and one bromine on the dash. There is another possibility, one on the dash and one on the wedge. Sorry, suppose this one the wedge bromine and this one the wedge, this one dash, this one wedge, like this. So as you can see, here we have 3 chiral center, here as well. If any one remains same in all the 3 chiral center, like this one, this is dash, this one is also dash, and there is a change on these two, so this kind of relationship is known as dash stereomer. Okay, so this is a pair of dash stereomer. Now number 9. This is a very easy one. So HBr, and again we have a this double bond left side and right side. So always check the carbocation stability. So if you are going to keep positive charge first on this carbon and again on this carbon, and then check the stability. Look at this. After attack of H, this CH becomes CH2 here if carbocation is on the benzyl carbon. The second possibility, this is supposed to be CH2 and this time this is CH plus, like this. Out of these 2 carbocation, the first one is a stable carbocation because positive on the benzyl carbon, and benzyl carbon, this one is in the resonance with the benzene ring, so this one is more stable. So if this is your carbocation, it means next step is what? Br minus is the nucleophile attack on this carbocation. So option A is right choice. The reason is that pH means benzene ring, okay? pH means benzene ring. The next question, number 10. The reaction of HBr with this alkene in the presence of peroxide. So this is anti-Markovnikov's addition of HBr. So the correct product will be this. Bromine attacks on the carbon which is, more hydrogen containing double bonded carbon. So this is called anti-Markovnikov's addition of HBr, anti-Markovnikov's. Now the next is HgSO4 with H2SO4, and this is Markovnikov's addition of OH. So if you are going to do the Markovnikov's, it means the OH attack on the carbon which is less, which has less hydrogen. So here we can attach OH, and we all knew this is enol. So now we will do the tautomerism. So tautomerism means double bond on the oxygen containing carbon and hydrogen on the neighboring carbon. So this is CH3, CH2, C double bond O, CH3. So this is keto form. So keto is more stable than enol. So option A is right here. Clear? Now number 12. So here we have a reduction of H2 nickel, and we have 2 alkene here, but only 1 mole we are going to take. So now the question is, which double bond is going to reduce by H2 nickel? So we can reduce that double bond which is less stable, and less stable means, if you remember like Sirjaf and Halfman alkene, then Halfman is a less stable one. Halfman means less substituted double bond. So if you look at this double bond, this one has less number of carbon chain, while this double bond has more alkyl groups. So this is highly substituted, which means stable, and this is less substituted. So this one is unstable one, so we can reduce this double bond. The top one, the ring one, will remain same. The right choice is C. Clear? So this one is anti-dihydroxylation. This is anti-dihydroxylation, and anti-dihydroxylation carried out by this reagent CF3CO3H. This is ozonolysis, this is syn dihydroxylation, okay? So CF3CO3H H plus with H2O, that gives you anti-dihydroxylation, which means one OH on the wedge and one OH on the dash. So this is all about the alkene and alkyne, the quiz. In the next session, we can do more questions of alkene, alkyne, or any other chapter. So please watch and subscribe. Thank you so much.